Around this time of year, I would be expecting that the advent of code videos were getting significantly harder, like way more challenging. But it looks like it's been staying kind of the same difficulty throughout. So let me know what you think about that in the comments. Maybe I'm wrong. Maybe I'm totally wrong. Maybe these are getting a lot harder. But it seems to me that they aren't getting that much more challenging. So today we're going to be doing Advent of Code Day 18. I'm going to be doing the problems and then explaining the solutions. So hopefully it helps. The code is going to be in a GitHub repository, which is linked to down in the description. And if you want to see any different days, then you can check out the playlist, which is also in the description. So today we're just going to be doing day 18, Operation Order. As you look out the window and notice a heavily forested continent slowly appear over the horizon, you're interrupted by the child sitting next to you. They're curious if you could help them with their math homework. Unfortunately, it seems like this math follows different rules than you remember. The homework, your puzzle input, consists of a series of expressions that consist of addition, multiplication, and parentheses. Just like normal math, parentheses indicate that the expression inside must be evaluated before it can be used by the surrounding expression. Addition still means addition, and multiplication still means multiplication. However, the rules of operation precedence have changed. Rather than evaluating multiplication before addition, the operators have the same precedence and are evaluated left-right regardless of the order in which they appear. For example, the steps to evaluate the expression 1 plus 2 times 3 plus 4 times 5 plus 6 are as follows. 3, 9, 13, 65, 71. Parentheses can override this order. For example, here's what happens if parentheses are added to form 1 plus 2 times 3 plus 4 times 5 plus 6, and it produces 51. And then there's a few more examples. Okay, before you can help with the homework, you need to understand it yourself. Evaluate the expression on each line of the homework. What is the sum of the resulting values? Okay, so this is basically just like a parsing input and like working with it emulator. Can't be too difficult. There's a lot of lines in here, which makes me a little bit nervous, but yeah, hopefully it shouldn't be too difficult. So I'll be back soon to explain the solution. Okay, so we have arrived at an answer. It's a pretty big answer, but alright, it's the right answer. Okay, so I guess it's time to explain the solution. So I've pulled up here a diagram, and I'll just explain this diagram because it's easier to like have some visual reference, I guess, if you can see this, to guide you, I guess, while I'm explaining. So first thing first, we're going to need an example. So let's just do 1 plus 2 times 3. This is going to be without any parentheses. 2 times 3 plus 4 times 5 plus 6. So first we're going to remove the spaces because the spaces make everything kind of complicated. So we're going to remove the spaces first and wait. Oh, okay, wait, we don't need... Ooh, I didn't actually remove the spaces, but I think removing the spaces just makes it run a little bit faster. So I'm just going to remove the spaces right here. And the reason for this is that because we don't actually need to go over unnecessary characters. Okay, so we're going to loop through the entire string, character by character, and we're going to keep track of 3 values while we do this. So first is index, and it starts at 0, because index just keeps track of which character we're on. So this would be 0, this would be index 1, this would be index 2, and so on. So wait, okay, hang on. So these are the indices, and wait, I can't click. Hang on. Okay, so after that, we also need to keep track of our current value. This is just our accumulator, which we apply our operations to. So if you can see over here in this example, we have, this is our accumulator. It's basically this number over here. So after 1 plus 2, it's going to be 3. After 3 times 3, it's going to be, wait, what? What? Oh, no, sorry. This is part 2. This is part 2. This is part 2. Okay. No, sorry, this is the wrong example. Okay, so it'd be 3, and 3 times 3 is 9, and then 9 plus 4 is 13. So this value over here is just our accumulator. And we're giving it a variable name called cur. Okay, we also need a value called next value. Actually, I called it prev value. So prev value is a string, actually, and it basically just counts the next string, I guess. So if our index is currently like, if we had a big number like 3, 4, 5, 6, 7, we would be looping through this thing, and we would need to keep the value of this number inside something called prev value. So as we increment through the string, we make prev value 3, and then we make it 34, and make it 35, 345, and so on. And then when we reach the next operator, for example, a plus sign, we would turn this prev value into an integer and then actually perform some operations on it. That's all we need. These are our variables. Oh, also, we need a fourth one called op. Op is basically just stores the most recent operation, so we can perform it once we're done evaluating a number. So op usually starts as an empty string. Okay, so we're going to loop through the string and provide some examples. So let's say we were in the middle of the string. All right, so we were at 3, and right here our index would be 0, 1, 2, 3, 4. Our index equals 4. Our current value, we just evaluated it, it'd be 3. Our prev value would be equal to empty char, and our operation would be equal to multiplication. So what do we do here? Okay, we need to parse this 3, and parsing this 3 turns our prev value into a 3. Okay, and then that's all we need to do. So we move on to this plus sign, and then our index equals 5. Current value is still 3, but what we do now is we say, okay, we have to actually evaluate this operation right here. So our prev value is still 3, operation is still multiply. So we take our current value, and then we multiply it by our prev value. So we do 3 times 3 equals 9. So we update our current value to be 9, and we assign our prev value to be empty and our operation to be empty because we're not done. After that, we also have to make sure operations is the current operation. So basically, operations just tell us to execute the previous operation because we're done evaluating numbers. And numbers tell us to keep adding numbers to our current or previous value, I guess. And yeah, that's basically it. For parentheses, we're going to need to do something more complicated. So let's get an example over here. Okay, 1 plus 2 times 3 plus 4 times 5 plus 6. Okay. 4 times 5 plus 6. All right. Okay, so how do we evaluate parentheses? Well, the idea is actually not that difficult. When we hit a parentheses, so for example, our index is equal to 2, and then we hit a parentheses, then we need to loop forward. So we need to skip forward until the parentheses are balanced. And by balanced, I mean that the number of left parentheses is equal to the number of right parentheses, because that means the parentheses expression is over. So for example, over here, we would keep going forward. Over here, we would see 2 left parentheses, and then over here, we would see 2 left parentheses and 1 right parentheses, and then finally over here, we see 2 left parentheses and 2 right parentheses. So when they're balanced, then we know the expression inside the parentheses is over, and then we take the expression inside the parentheses, we evaluate it, so this is kind of recursive, but we evaluate the expression inside, and then this whole thing just gets turned into 6. And then we evaluate it as normal. So that's how parentheses work. Now, let's kind of go through the code. I won't go too much in depth because it's kind of complicated, but it's actually not that complicated. It's basically what I just explained right there. So here are our values. We have an index, we have a current value, we have a previous value, to store, the numbers that are a bit long, and then we have an operation. So we loop through the entire expression. So while the index is still valid, while it's not out of bounds, the current character, this is just to simplify things a little bit, so we don't have to write expression index every single time. So if it's a digit, then we just add it to our previous value to, accumulate the number. Otherwise, if it's an operation, we need to execute the previous operation because we know the number is done parsing. So if it's a plus sign, then we need to add our previous value to our current value. Otherwise, we need to multiply. Otherwise, if the operation is actually empty, that means we haven't done any operations before. And that means we just have to store it. That means this is the first operation. So everything before is just a number or something in parentheses. So that gets, we just turn our previous value into our current value because that's how we need to initialize it, right? At the end of all that, if it's an operation, regardless of what operation it is, or if it's empty, um, or regardless of what the previous operation was, we still need to reset our previous value because we're done evaluating the previous number, and our operation becomes whatever character was there, either a plus or an multiplication sign. Otherwise, if it's a left parentheses, we need to balance it out. So you can see right here, this is analogous to what I explained. We keep track of how many left parentheses there are and how many right parentheses there are. And then we need to keep track of our starting index because we also need to keep track of where to start our actual parentheses expression. And while they are unbalanced and while the index is still valid, we need to balance it out. So that's what we do over here. Once they're balanced, then we need to evaluate the expression. We just get the expression by taking a substring and then we evaluate it. So that's it for parentheses. After that, we increment the index because, we have to move forward. At the very end, we don't have any operation after the string to tell us to execute the previous one, so we need to execute it ourselves. If there was an operation in the string at all, which there probably should be, then we need to do it. So current value and previous value are still valid. Previous value is just the number at the very end. And operation is still going to be a plus or multiply if it exists. At the end, we just return our current value, and that gets returned. So, yeah, that's it for the evaluating function. That took quite a lot of lines, but I included comments and tried to make it as clear as possible. It doesn't have to be concise because that's hard to read. Okay, at the end, we need to sum all of the expressions. So it starts at 0, and then we just evaluate every single one and add it to our accumulator. And at the end, we just return it. So that's it for part 1. Let's move on to part 2. All right, you managed to answer the child's questions, and they finished part 1 of their homework, but get stuck when they reach the next section, advanced math. Now, addition and multiplication have different precedence levels, but they're not the ones you are familiar with. Instead, addition is evaluated before multiplication. For example, the steps to evaluate the expression 1 plus 2 times 3 plus 4 times 5 plus 6 are now as follows. 231. Okay, what do you get if you add up the results of evaluating the homework problems using these new rules? Okay, so now we need to do addition before multiplication, and this might require restructuring our code a little bit, but that is totally okay. So let's get started. And at last we have arrived at our answer, which is this huge number over here. It's right, let's go. Okay, so let's explain the problem. So let's explain part 2. It's a little bit complicated, but that's okay. We're going to work through this together, all right? So the idea here, hang on. Okay, so wait, what? Okay, the idea here is basically if we're given an expression, let's take one of the examples like let's see, 1 plus 2 plus, okay, let's use the same example. All right, 1 plus 2 times 3 plus 4 times 5 plus 6. So the idea here is to evaluate addition first, right? So we have to do this, and then that, and then that, and then we multiply them all together. So we notice that at the end, we're just going to have a bunch of products. We're going to have 3 times 7 times 11. This is what we're going to be left with. So we're always going to have a product of some numbers. So in the code over here, we have an array that's called multiplicans, and these are just the numbers that we have to multiply together at the end. And how do we get there? Well, how do we get to 3 times 7 times 11? Well, we just have to evaluate all the additions, right? So when we get to an addition sign, we use the same strategy as above. We also have a index. It starts at 0, and we have a prev value, which starts at empty string, and prev value just accumulates whatever number was there previously. So prev value, when we get to this addition sign, is going to be 1, and then we need to loop forward until we hit a multiplication sign or we hit the end of the string. Once we do that, we know our addition thing is complete. So for example, if we had something like 1 plus 2 plus 3 plus 4 times 5, then once we hit this addition sign, we're going to loop forward over here until we hit this multiplication sign, then we stop. And then we have our summons array. And summons is basically what we need to add together. Because we know that once we loop until we hit a multiplication sign, or we hit the end of the string, then we know we only have additions. So we want to sum all of these numbers over here, and that produces a summons array. But you might be wondering, well, what if there's parentheses, right? So we have 1 plus 2 plus maybe 3 times 3 plus 4 times 5 plus 6, right? Then we need to evaluate these parentheses first, but other than that, it's basically the same. We have our summons array. It becomes 1, 2. Once we evaluate this, it evaluates out to 35, and then we have 6. So that's pretty simple. We have a summons array, which counts the sum for everything that's in between the multiplication signs, right? So let's do another example. Let's do this one. I don't know how I'm gonna do this, but there we go. Okay, let's make this super big. All right. So what we do here is our multiplicands are gonna be this. Oh no, that, and that, right? So what we do is when we hit a parentheses in the main expression, we also have to evaluate that first. So this evaluates out to 54. We're not going to go into the details of how we evaluate that because it's recursion, and you only kind of want to do the top case for recursion when you're explaining it. So yeah, over here, okay, fine. We might have to go into deeper level, but okay. So this is going to be 15 times 14, and then this is plus 6. So this becomes something big. Let's just call it x. And then we have to add 6, and then these become our multiplicands. And how we know this is when we hit this parentheses, we go until the end of the parentheses, and that becomes our first summoned. And our first summon is 15 times 14. Then we go forward and we hit the 2. So that's a 2 for the summons. Then we go forward, we hit the 4, that's another summons, and then we hit the multiplication sign, we're done, and this is just our summon, and then we sum it together, and that becomes x plus 6. That's our other term in the multiplicands. And then at the end, we just have this 2, and that 2 just becomes the end of the multiplicands. So that's the idea here. We just turn this into a list of numbers that we have to multiply together, and then if there's addition signs, then we go through all the consecutive additions and just evaluate them together. So the code is pretty long. You might want to take a look at it yourself. It's in the GitHub repository, which is linked to in the description. So we start out with a few variables that are a little bit different this time. So we have multiplicands, we have previous value to keep track of the previous value, index as always, and last is addition is actually to make sure that the last is actually to tell us if the last operation is addition, because that helps us in determining whether the last number should be added to the multiplicands array. I'll explain that at the end. So we just go through the entire expression again. We also alias expression index to char. If it's a digit, we still add it to our previous value. If it's a plus sign, then our strategy, remember, is to loop until we hit a multiplication sign or we hit the end, right? So we keep a summons array which starts with int previous value because, for example, when we're starting here with 1 plus 2 times 3 plus 4 times 5 plus 6, when we hit this addition sign, we can't just keep going until we hit multiplication sign or the end. We have to actually include this string as well. So we add that to our summons array. We also set our previous value to empty string, just to keep track of it. And then we loop through while we still can, while the index is valid. If it's a digit, we add it. If it's a parentheses, we evaluate the parentheses using the same code that we actually used over here, and assign that the result of the expression assign the parentheses into a previous value variable, into the previous value variable. If it's a multiplication sign, we break. If it's a plus sign, then we just add whatever we had before into our summons array. So for example, over here, when we hit this addition sign, our previous string would be 2, and we just add that to the array. At the end, if it's addition all the way through, so for example, in this example over here, we would hit the end knowing that this is an addition sign. So that's important for later. If the previous value is not null, then we also have to add the last value to our summons array because we didn't have any plus signs to prompt that. Yeah, and then at the end of all of that, we add that to multiplicands because we evaluated the consecutive sum. If it's a multiplication character, then we add that to the, we just add that to our multiplicans list. If it's parentheses, we evaluate that and add that to our multiplicans list later, actually. Yeah, later, because we need a multiplication sign to prompt that. Okay, at the end, this is where the last is addition variable comes in handy. Basically, if the last number in the expression is going to be added, then we don't need to add it to our multiplicans. But if it was multiplied, so for example, in this example, if we added a times 7, this would evaluate it to 13, this would evaluate to 7, this would just be 1. Oh, sorry, this would be 3. We need to know if this is an addition sign or a multiplication sign. If it's an addition sign, then we don't actually need to do anything because it'll be included, and this would be 20 if that was addition. But we know it's not addition, it's actually multiplication, so our multiplicans array needs to be extended from 3, 7, 13 to 3, 7, 13, 7. And that's basically it. At the end, we just multiply everything together, and then we evaluate everything together. This was just for debugging. We don't actually need that. But I'll leave that in there just in case you want to debug it yourself. So, yeah, this is just parsing the input and evaluating it as we did in part 1. So that's it for Advent of Code Day 18. Hopefully that made sense. Hopefully that helped. Please, as always, leave any feedback in the comments or DM me on Discord, or just leave a like on the video if it was helpful. That's feedback as well. Additionally, you can help support me by hitting that subscribe button. It really helps me a lot. I'm trying to get to 400 by the end of the year. So if you enjoy my content, please support me so I can make more. Yeah, that's it for Advent of Code Day 18. And looks like we've arrived on a new continent. Might be a few more days before we get to our vacation island. But so far, it's been pretty good. There hasn't been any ridiculously difficult problems for me. So, yeah, I guess that's it. Thanks for watching, and I will see you tomorrow with Day 19.